All right, so today we're going to be talking about, well, I think we kind of did this already, but I'm just going to put it in the video, box plots. The main thing you need to know when looking at a box plot is that this is the minimum, that's Q1. This is the median, Q3, and the maximum. And this creates four sections, or the four quartiles. From the minimum to Q1 is going to be 25% of the data. So if you interviewed 100 people, 25 data points are in this section. Clear? From Q1 to the median is another 25% of the data. So if you interviewed 100 people, 25 of that information is there. So each of these contains 25% of the data. So this right here is considered the 25th percentile. This one is considered the 50th percentile, and this one is the 75th percentile. Why? Because at this point, how much data is below you? 25. At this point, at the median, how much data is below you? 50%, two quartiles. At Q3, how much data is below you? Since you have three quartiles, that's 75%. Okay? And at this point, how much data do you have below you? All 100% of it, okay? All the data. The maximum being the point that's the highest point. So there's you should know that the middle 50% of the data lies between Q1 and Q3. And this area is known as the interquartile range. The difference between 12 and 7 is known as the interquartile range. So far, so good? I guess we did this yesterday. You all look a little. All right, this box plot is about what? All right, so this over here is the cost in dollars of how many CDs? Of 12 CDs. So the line is the dollars. 12 CDs is just outside information. Which cost is the upper quartile? Everybody has it. Nick will help you find it. He thought he didn't have it, but he did. It's also right next to 12. All right, which cost is the upper quartile? First of all, which section is the upper quartile? Well, the upper quartile is Q3. So what's the cost at Q3? Right, this is Q3. And what is this value right there? 26. So the cost at the upper quartile is $26. What is the range? If they just want the range of the whole thing, then you're going to do maximum minus minimum. Okay. The maximum is not 30. The maximum is the end of the whisker right here, which is how much? 29. And how much is the minimum? 7. So what is 29 minus 7? 22. So the range is $22. From the cheapest to the most expensive, there's a difference of $22, okay? What is the median? Okay, so when you look at the median, do you see that it's not exactly at 20? 20.5. You guys are so quick at the uptake. Good job. All right, which cost represents the 100th percentile? Which cost represents the 100th percentile? D. Which cost represents the 100th percentile? Look at the notes, people. Exactly. The 100th percentile is going to be here at the max, right? And the minimum is going to be the 0th percentile. So somebody said the answer already. I heard 29, correct? Why? Because that's the maximum. All right, how many CDs cost between $14.50 and $26? How many CDs cost between $14.50 and $26? No, it's not 12 CDs. 12 CDs is the total. Between 14.5 and 26, how much data do we have? Right, so basically we're asking from here to here, the box. How much data is found in this box? 50% between both of them, clear? And this data is about what? The box plot below is about of 12 CDs. So what does that mean? It means they took 12 CDs and they said, what's the cost of this CD? What's the cost of that CD? What's the cost of this CD? What's the cost of that CD? And then those prices is what they've plotted here. Clear? Okay. So 50% of the data talks about how many CDs? 50% of the data talks about how many of those CDs? Okay. 12 CDs is 100% of the data. The cost, the price of 12 CDs is 100% of the data. You have 12 prices. If you're only talking about 50% of the data, how many CDs are we talking about? Yes, 50% of 12 is 6. Remember, you got to turn this into a decimal point 5. Right? So 6 CDs. This is not money. How many CDs cost less than 14.50? Where is 14.50? 14.50 is at Q1, clear? How much data is below Q1? 25%. Clear? And what's 25% of 12? All right, for those of you wondering, how do I do this? It's 0.25 times 12, which is 3 CDs, cost less than 14.50. So some of these questions were about the cost of the CDs, and some of these questions were about the quantity of CDs. Are we clear? Okay, what's going on with the hands being raised? All right. In looking at the next practice questions, this box plot is about what? Invasion of privacy. What is this box plot about? How many? Yes, well, the 40 is going to be important, so you need to pay attention. So this data is about 40 adults, the height of 40 adults. So we have 40 data points. Are we clear? Does that make sense? One height per person. And so we're plotting their heights, and we created a box plot of the data. Clear? All righty. Now, answer questions A, B, C, and D. Go. Okay, so it says height range. Right? Range means the difference between the two numbers. Clear? What is the height range of the middle 50% of the surveyed adults? Where is the middle 50%? Right? From Q1 until Q3. What's the value of Q1 and Q3? So all you gotta do is 72 minus 63. 65, 7. So 7 inches. The height range of the middle 50% of the data is 7 inches. Okay, the shortest person to the tallest person in that range, there's only a difference of 7 inches. How many of the surveyed adults are between 72 and 79 inches? Okay, so what do? You find 72 and you find 79 on the box plot. Right? 72 is here and 79 is over here, which is the maximum. Clear? Okay, so how much data is between Q3 and the maximum? 25%. Okay, so 25% of the data is in that section. So how many adults is that then? What's the total number of adults? The total number of adults is 40, but we only want 25% of that, right? So 0.25 times 40 equals 10 adults. I didn't hear you. So I did not realize that you had said that already. Are we clear? So it was not my intention to ignore you. I really didn't hear. Okay, I thought you were talking to me. All right, what percent of the adults are 72 inches or shorter? So what do? You go to your box plot, find 72. How much data do you have below 72? Right, this is Q3. How much data is below Q3? No, it's not 25. Pay attention, I'm going to explain it again, okay? I'm going to explain it again. 75 is the answer, but it's not a guess, it's something that we need to know. This is the minimum. This is Q1. This is the median, Q3, and this is the maximum. Between here and here is 25% of the data, quartile, a quarter. Another 25%. That means together, from here to here is 50% of the data. This is also 25%. And this one is 25%. I believe we're at Q3, right? So how much data is below Q3? 3/4, which is 75%. Clear? And is that what they want, the percent? Yeah, so 75%. 75% of the adults are 72 inches or shorter. All right, so what is the height of the tallest adult surveyed? 80? 79 inches, right? Okay. About 10 people have a height below what amount? Well, this is where you realize that 25% of the adults are 10. So there's 10 adults here, 10 adults here, 10 adults there, and 10 adults there. So from Q1 and lower, you have 10 adults. Clear? What's the value of Q1? 65? Okay, so about 10 people have a height of 65 inches or lower. About 20 people have a height above what amount? 20 people is how many quartiles? 2 of them. So that means from here, there are 20 people going this way, right? What is this measurement at the median? Louder. 61? 69? 68? Well, say it louder. I can't hear you guys. All right, so about 20 people have a height above 68 inches. So once again, you have to learn how to read box plots. This is what I'm trying to do, show you the different types of questions that you're going to be asked. How many of the surveyed adults are at least 58 inches? At least means what? What? Minimum amount. So you can be 58 and you can be higher, but not lower. So find 58. Oh yeah, that's right. It's the minimum, isn't it? Yeah, so 100% is above that point, right? So how many? Oh, so that would be all 40 of them. What type of distribution do we have? Hmm. It's wrong because they're not asking you for the percent. They're asking you for the number of adults, okay? So what type of distribution do we have? Symmetric, skewed left, skewed right, uniform? Y'all sure? Okay, why? What's your proof for this claim? I can't hear you. I know you're talking because I can see your mouth moving, but I cannot hear you. The tail is longer on one side. That would not make it symmetric. Okay, skewed right. All right, so let's measure this. This is how you get, remember I told you if you make a claim, you got to have evidence. Clear? Let's get our evidence. How long is this tail? How long? It's not 72. From this point, from 72 to 79 is how much? 7 inches. How long is this tail? From 58 to 65 is how much? 7 inches. The tails are identical. So no tail is longer than the other one. Okay. Now let's check here. We know this is the median, right? What's the distance from the median to Q3? People, 68 to 72. Guys, can we please count lines? 4 inches. Thank you. What about over here? From here, 3. So is the left side a mirror image of the right hand side? No, but it's close enough, right? It's symmetric. But I had evidence and you did not. Huh? All right, new information. When I ask you questions, you're going to be comparing, you're going to be looking at this table of information. Are we clear? Got it? All right, so we're going to be comparing the centers and the spread of the data. The center of the data and the spread of the data. Okay. Um, how do we compare the centers? We compare the centers by looking at the mean or the median. And here's how you know which one you're using. You're going to use the mean if your data is symmetric and you have no outliers. You're going to use the median if you have skewed data with outliers. If you're skewed left, the mean is smaller than the median. If you're skewed right, then the mean is greater than the median. Clear? Okay, good. Now, if we're comparing the spread, we're going to look at the MAD, okay? When we're comparing how spread out the data is, we're looking at the mean absolute deviation. If your data is spread out, then you're going to have a greater mean absolute deviation. If your data is close to itself, then you're going to have a smaller mean absolute deviation. Okay? So if they ask you, hey, compare, describe the spread, then you will use the mean absolute deviation to describe the spread. Clear, clear, clear? All right, so looking at these two dot plots, which data set will have the greater mean absolute deviation? Mean absolute deviation measures what? It measures the spread of the data. How spread out is the data? So which one has data that's more spread out than the other one? The set 2, right? Because you have this value over here, which is between 20 and 30, and all the other ones are between 50 and 60. And here, everybody is between 50 and 60, so they're closer together. All right, so then this one right here would have a greater MAD. Why? Because the data is more spread out. Right. All right, different question. The following data set represents test scores from Unit 11. Compare the mean and the median. All right, we're on a test. What's the quickest way of doing this? Okay, so let's go to Desmos. All right, so in Desmos, I recommend that you make a list of the elements. So I'm going to call it L in brackets, okay? And type in your numbers. Make sure you type them in correctly. I'm trying to look at the numbers so that I don't mess them up. All right, so the first thing I would be to create a set of the data, okay? I called it L. All right, the next thing is I need the mean and the median. So what do I type in Desmos? Stats. Stats, parentheses, L, right? And it gives me the following statistics. It gives me the median, but it does not give me the mean. All right, so the median is 82.5. So how am I going to get the mean? Guys, we're on a test. Answer quickly. We did stats, but it only gave us the median. So what do we do? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19 students. What do we do? The teacher is not going to help you because she's testing you. During the assessment, I'm testing you, not teaching you. Let's go. Guys, what does the question say? What is the question? Okay, we have the median, so what do we have to do now? Yes, and how do I do the mean? No, you type the word mean instead of stats. Oh my gosh, pay attention. You type the word mean instead of stats to get the mean. And it's 77.7. All right, now that you know what to do, this is the fastest way, okay? It says to compare them. What can we tell about the data just by looking at these two numbers? The median is bigger. And what does it mean when the median is bigger? The mean and the median don't measure spread. Exactly. The mean and the median measure the center of the data. And when your median is higher, it means that your data is skewed. Okay? All right. Can I what? You know you also have this table right at the top of your paper, right? All right. Now, we know this tells us that the data is skewed because they're not equal. It's if they're equal or very close to equal, like maybe just off by one or two, then we know that that's symmetric. But because one is bigger than the other, we know that the data is skewed. And actually, we can tell whether it's skewed left or right. Clear? Because you have to remember, this is a number line. Number line. So it goes from the smaller number to the largest number. Clear? So which one is smaller, the mean? So you have the mean here, which is a smaller number, and you have the median over here. The mean goes towards the tail. So that means most of the data is over here. So what type of skew, in which direction is this data skewed? On the left. So this is skewed left. If it was the other way around, then it would be skewed right. Oh, and wow, this actually, what type of distribution? Sorry, skewed left. So what does that mean when you're skewed left? What does that mean about the data? What causes that tail? All right, so you have outliers on the left, correct? Outliers are numbers that are so far off from the rest of the data. So for example, if you look at the test scores, which one would you think is an outlier? Which one? 38 could be one. What's another potential one? Okay, 41. But we can't just say there's an actual calculation that has to be done to prove whether something is an outlier or not. Are we clear? So let's go ahead and get this done. Are there any outliers? So we need to check. Now, take out your formula sheet. Now, why am I doing this? I'm trying to make you independent. I shall go through the motions so that you learn how to do this on your own. Go to your classwork in your class. Right, and one of the things you're going to find is your algebra formula sheet right there. Or if you have your pink one, go ahead and take it out. But I have a feeling that everybody has the pink sheet, so. All right, when you go through the formula sheet, you're going to find that this section right here gives you information about statistics. And what does it say about outliers? Okay, 1.5 times the interquartile range. What is the interquartile range? The formula sheet tells you. What is the interquartile? Right? It's basically the Q3 minus Q1. Clear? All right, so now let me teach you how to calculate which ones are outliers. The lower outliers, right, are going to be Q1 minus 1.5 times the IQR. So we got to calculate a few things. We need the IQR. Yeah, we have to calculate what's Q3 minus Q1. First of all, what's Q3? Huh? How do we know this? Okay, wait. I got to put it on the video. Okay, so stats, right? All right, Q3 is 89 and Q1 is 77. So 89 minus 77 is how much? How much? 4? Okay. Thank you. It's not 4, it's 12, right? Because in the calculator we did 89 subtract 77. Also on the number line, we started at 89 and we went 77 to the left and we ended up at 12. Another question. Please engage so that you know what you're doing when you're on your own. And you're not asking me on a daily test because I will not answer. All right, so we know that IQR is 12. Clear? And Q1 we said was 77. So 77 subtract 1.5 times the 12 is how much? 59? So numbers 59 or lower are outliers. Or I should say lower outliers, okay? All right, so just from this, which of the numbers are 59 or lower? 41 and 48, right? 38? Not the 66. The 66 is not an outlier because it's bigger than 59. So far, so good? That's the lower outliers. Let's calculate the upper outliers. Please take careful notes. The upper outliers are going to come from Q3, right? From the upper side. And it's going to be plus because there's the numbers that are going to be bigger. So much bigger that they're out of range towards the right, okay? Plus 1.5 times the IQR. Sorry, my IQR came out weird. All right, from the calculations that we did before, Q3 is 89. Do we agree? Plus 1.5 times 12. How much does that give us? How much? 107? All right, so the numbers that are 107 or greater are, ooh, that is not how you spell greater, Miss Medina. Greater, 107 or greater are outliers. Okay. Do we have any outliers? No, no upper outliers, right? But we do have two lower. All right, based on today's, remember I told you the questions were going to come from this table right here. Now, what measure of center best describes the grades and why? Which one? No, what measure of center? What are the two measures of center? Look at the table at the top of the paper. Deanna, what are the two measures of center? Mean or the median? So which one are we going to use based upon this data? Huh? Median, why? That's not what the table says. It doesn't say that you use the median because it's the level. Because it's skewed left. Are we clear? There we go. Median because data is skewed left. By the way, let me teach you something. Y'all ready? You sure? You got to be paying attention, otherwise you're not going to learn this awesome new trick. Instead of stats, please don't make fun of me teaching you. It's pretty cool. You're going to put box plot. And yes, and look, if you click exclude outliers, you can see the tail, the left tail. Remember we said it was skewed left? And if you click on exclude the outliers, it'll tell you where they are. You got to hit this little plus sign, magnifier plus sign. And if you click on the circles, it tells you their values. So you know exactly which ones in the data are outliers. Which means we could have done this from the get-go to get our outliers. But then I wouldn't have been able to teach you how to calculate the outliers. There we go. I don't know what to tell you. All right, we shall continue with histograms. But please make sure that you review this, dot plots, box plots, do your assignments because tomorrow we're going to have an assessment, okay? Sound good? Don't be absent.